The universe is trying to kill you. Gently, I'm floating in the middle of nowhere. Complete darkness surrounds me. No sound, no air, just the cold, infinite void of space. And I have exactly 90 seconds before my body starts to fail in ways you don't want to imagine. Space is beautiful. We see those stunning images from telescopes, those swirling nebulas in purple and gold. And we think it's this majestic cosmic art gallery, and it is. Until you realize that out there, right now, there are invisible explosions powerful enough to sterilize our entire planet. Wandering planets the size of Jupiter, drifting through the darkness with no star to call home. And a theoretical event that could erase reality itself, spreading outward at the speed of light, giving us absolutely zero warning before everything we know simply stops existing. Welcome back to the channel. I'm your host, and today we're counting down the most terrifying facts about space that are actually true. Not clickbait, not science fiction. Real phenomena that scientists have observed, measured, and in some cases are actively monitoring right now. But here's the thing. Before you start building that underground bunker, we need to establish some ground rules. Because scary doesn't mean happening to you tomorrow. Throughout this video, I'll give you both sides, the nightmare fuel and the actual risk assessment. Think of it like this. Yes, there's a chance you could get struck by lightning, but you still go outside, right? If you're ready to confront some cosmic horrors while keeping your sanity intact, hit that subscribe button and ring the bell. Trust me, you're going to want to stick around for number 3. And drop a comment right now. What's the space fact that keeps you up at night? Let's see if it made my list. Let's start with something that sounds like it came straight out of a sci-fi disaster movie, except it's very, very real. Number 7, gamma ray bursts. Picture this. Somewhere in a distant galaxy, a massive star, maybe 30 or 40 times the mass of our sun, reaches the end of its life. In its final moments, it doesn't go quietly. It collapses into a black hole, and as it does, it releases more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. This energy erupts in 2 focused beams, shooting out from the star's poles at nearly the speed of light. These are gamma ray bursts, or GRBs, and they're the most powerful explosions we know of since the Big Bang itself. Now here's where it gets terrifying. If one of these beams happened to be pointed at Earth from a star within a few thousand light years, it would hit our atmosphere like an invisible hammer. The gamma rays would strip away our ozone layer in seconds, the protective shield that guards us from harmful solar radiation, gone. Within hours, the sky would fill with nitrogen dioxide, turning it brown. The increase in UV radiation reaching the surface would devastate ecosystems. Phytoplankton in the oceans, the base of the marine food chain, would die en masse. On land, DNA damage would spike. We're talking potential mass extinction. Scientists actually think a GRB might have been responsible for the Ordovician extinction event about 440 million years ago, when nearly 85% of marine species disappeared. So, should you be losing sleep over this? Here's the reality check. We've identified the stars most likely to produce dangerous GRBs near us. Stars like WR104, and they're all over 5,000 light years away. The danger zone is probably around 6,000 light years, and crucially, we have no evidence that any nearby candidate stars have their poles pointed at us. GRBs are also incredibly rare in any given galaxy. The statistical odds of one hitting Earth in our lifetime, or even in the next million years, are vanishingly small, but they do remind us of something important. Space doesn't care about us. These cosmic events happen on scales we can barely comprehend, and we're just fortunate to be far enough away from the shooting galleries. Let me ask you this. Are you more scared of things that could happen or things that are happening? Drop a GRB in the comments if this one got under your skin, or if you think the next one is worse. Because trust me, we're just getting started. Number 6, rogue planets. Let's talk about something that shouldn't exist, but does. Billions of them, actually. Imagine a planet, not orbiting a star, no sun to warm it, no light, just a frozen, dead world tumbling through interstellar space in complete darkness for billions of years. These are rogue planets, and current estimates suggest there could be more of them wandering the galaxy than there are stars. Think about that. Trillions of invisible worlds, some potentially the size of Jupiter, some maybe even Earth-sized, just drifting through the void. They were either ejected from their solar systems during formation, gravitational interactions basically throwing them out like cosmic garbage, or they formed in isolation from clouds of gas and dust, never bound to a star at all. Here's the nightmare scenario. What if one of these invisible giants was heading straight for our solar system right now? It wouldn't show up on most of our telescopes because it emits almost no light. We might not see it coming until it was already here, its gravity starting to perturb the orbits of the outer planets, then the inner planets, potentially flinging Earth out of the habitable zone or sending us spiraling into the sun. Reality check time. Space is really, really big. I mean, incomprehensibly vast. The distances between objects are so enormous that even if our galaxy contains billions of rogue planets, the chances of one passing anywhere near our solar system are infinitesimally small. We're talking winning the lottery while being struck by lightning levels of unlikely. Our solar system has existed for 4.6 billion years, and in all that time, no rogue planet has come through to mess things up. The math is on our side, but they're out there, in the darkness, wandering, and that's eerie enough on its own. Quick question for engagement. If you could visit a rogue planet, would you? Something about those dark, frozen worlds is both terrifying and fascinating. Let me know in the comments. Number 5, black holes and spaghettification. Everyone knows black holes are scary, but do you know exactly how they'd kill you? Because it's worse than you think. Let's say you're approaching a stellar mass black hole, about 10 times the mass of our sun. As you get closer to the event horizon, that point of no return where not even light can escape, something bizarre starts happening. The gravity pulling on your feet becomes significantly stronger than the gravity pulling on your head. We're not talking a little stronger, we're talking exponentially stronger. This differential is called tidal force, and it starts stretching you. Your body begins to elongate. First, it's uncomfortable, then it's painful. Then your bones start to crack and separate. Your internal organs stretch like taffy. Scientists have a technical term for this process, spaghettification, because you literally get turned into a strand of spaghetti, stretched thinner and thinner until you're just a stream of atoms spiraling into the black hole. And here's the truly mind-bending part. From your perspective, assuming you somehow survived the stretching, you'd cross the event horizon and see the universe outside speed up, watching billions of years pass in moments due to time dilation. From an outside observer's perspective, you'd appear to slow down and freeze at the event horizon, your image red-shifting until you simply faded from view. You never quite seemed to cross it from their frame of reference. Now the good news, if we can call it that, the nearest known stellar mass black hole is about 1,500 light-years away. V616 Monocerotis. There are probably closer ones we haven't detected yet, but even the closest theoretical candidates are hundreds of light-years distant. Black holes don't roam around sucking things up like cosmic vacuum cleaners. They're actually quite compact, considering their mass. If our sun suddenly turned into a black hole, which it can't because it's not massive enough, Earth would continue orbiting normally. We'd freeze because no more sunlight, but we wouldn't get sucked in. Still, black holes represent one of the most extreme environments we know of, places where the laws of physics as we understand them break down. And that's terrifying in its own right. Before we continue, do me a favor. If you're enjoying this reality check on cosmic horror, give this video a thumbs up. It helps more people discover the channel. And I want to know if you want more episodes like this. The algorithm feeds on engagement, so let's feed it. Number 4, vacuum decay. Okay, this is where things get really theoretical, but also really disturbing. What if I told you that the entire universe might be in a false vacuum state? That reality as we know it might just be a temporary bubble, and at any moment, a true vacuum could start spreading outward at the speed of light, fundamentally rewriting the laws of physics and destroying everything in its path. Welcome to the vacuum decay hypothesis. Here's the idea. Quantum field theory suggests that the universe exists at a certain energy level. We call this a vacuum state. But vacuum here doesn't mean empty space. It means the lowest energy configuration of all quantum fields. Now, what if we're not actually in the lowest possible energy state? What if we're in what physicists call a false vacuum? A local minimum that seems stable but isn't truly the ground state? If that's the case, quantum tunneling could allow a tiny region of space to suddenly transition to the true lower energy vacuum. This would create a bubble. Inside the bubble, the laws of physics would be different. Fundamental constants might change. Atoms might not hold together the same way. And here's the kicker. This bubble would expand outward at the speed of light. You wouldn't see it coming. One moment you're here, the next moment you and everything around you is transformed into something completely different. Assuming anything could exist at all in this new state. Before you start panicking, let me hit you with the reality. This is highly extremely, incredibly speculative. We have zero evidence that we're in a false vacuum. Current measurements of the Higgs field actually suggest we're probably okay, though there's some theoretical uncertainty. More importantly, if vacuum decay were likely to happen on human timescales or even cosmological timescales relevant to complex life, it probably would have happened already. The universe is 13.8 billion years old. We've had a long time for this bubble to nucleate somewhere and reach us. The fact that we're still here is actually a pretty good sign that either we're in a true vacuum or the false vacuum we're in is stable enough that the universe will die of heat death long before vacuum decay becomes an issue. But man, it's unsettling to think about. The idea that reality could just end everywhere, all at once, with no warning and no way to stop it or escape it. Let me know in the comments, is vacuum decay the scariest one yet? Or are you still more worried about the gamma ray bursts? Number 3, strange matter. This one is a bridge to something we're going to explore in much more detail in the next episode, but it deserves a mention here because it's genuinely bizarre and potentially apocalyptic. Inside neutron stars, matter is compressed to densities we can barely imagine. Protons and electrons are crushed together to form neutrons, and these neutrons are packed so tightly that a teaspoon of neutron star material would weigh about 1 billion tons. But some physicists theorize there might be an even more exotic state of matter called strange matter, where quarks aren't bound into individual protons and neutrons anymore, but exist in a sort of quark soup, with strange quarks mixed in. Here's the scary part. Some models suggest that strange matter might be more stable than normal matter. If that's true, then a chunk of strange matter coming into contact with normal matter could convert it. Kind of like Ice 9 in Kurt Vonnegut's novel Cat's Cradle. One touch and the conversion begins, spreading through the entire planet, converting Earth into a strange matter blob. We think strange matter might exist in the cores of certain neutron stars, which would make them strange stars or quark stars. If one of these objects collided with a normal neutron star, or if a chunk of strange matter got ejected into space during a collision and somehow made its way to Earth, it could theoretically start the conversion process. But here's the thing, we have no confirmed evidence that strange matter exists. It's theoretically possible, but we've never observed it. And even if it does exist, the chances of encountering it are astronomically remote. Space is vast. Collisions between neutron stars are rare, and the debris from such collisions would need to travel across interstellar distances and somehow intersect with Earth. The numbers don't favor it happening. Still, the concept is nightmare fuel. The idea that a tiny pebble of exotic matter could end our world is the kind of thing that science fiction writers dream about, and we'll be exploring strange stars and other extreme objects in the next episode, so make sure you're subscribed. Number 2, the vacuum of space itself. Let's strip away the exotic physics and massive explosions for a moment and talk about something simpler but equally deadly: space itself. Space is mostly nothing. In the interstellar medium, you might find 1 atom per cubic centimeter. In the intergalactic medium, it's even emptier. This vacuum, this near total absence of matter, is lethal to unprotected humans in ways that movies usually get wrong. If you were suddenly exposed to the vacuum of space without a suit, you wouldn't explode. You wouldn't instantly freeze either, because freezing requires something to transfer heat away from your body. and there's nothing out there to do that efficiently. Here's what would actually happen. Within 15 seconds, you'd lose consciousness as the oxygen in your blood depletes. Your lungs would be damaged if you tried to hold your breath, so you'd exhale immediately due to the pressure difference. The water in your tissues would start to vaporize at body temperature because there's no atmospheric pressure to keep it liquid, causing swelling. You'd develop something called ebullition, where gas bubbles form in your bodily fluids. Ultimately, you die from hypoxia, lack of oxygen to the brain, within about 1 to 2 minutes. If you were somehow brought back into a pressurized environment within that window, you might survive, though with serious injuries. Space is lethal not because it's dramatic, but because it's fundamentally incompatible with human life. We evolved in a thick atmosphere at the bottom of a gravity well, surrounded by air and water. The vacuum is the opposite of everything we need, and this is why spacecraft and spacesuits are engineering marvels. Every seal, every layer, every system is designed to maintain a tiny bubble of Earth-like conditions in the most hostile environment we know of. One small puncture, one failed valve, and you're fighting for your life against the void. We've explored amazing extremes so far, but I want to hear from you. Which of these facts surprised you the most? Hit me in the comments. And if you've made it this far, you're clearly into this stuff, so share this video with someone who loves space or science. Let's spread the existential dread together. Number 1, the time scales. We've talked about explosions, wandering planets, black holes, exotic matter, and the void itself. But you want to know what's actually the scariest thing about space? It's time. The universe is 13.8 billion years old. Our sun is about halfway through its 10 billion year main sequence lifespan. Humanity has existed for maybe 300,000 years, depending on how you define humanity. Civilization as we know it is only about 10,000 years old. We're a blip, a momentary flicker. And here's where it gets heavy. The universe has many potential endings, and all of them happen on timescales that make our existence seem not just brief, but almost imperceptible. There's heat death, where the universe expands forever and all energy becomes evenly distributed, leaving nothing but cold, dark emptiness. That's maybe 10 to the 100 years from now, give or take a few powers of 10. There's the Big Rip, where accelerating expansion tears apart galaxies, then solar systems, then planets, then atoms themselves. There's the Big Crunch, if the universe stops expanding and collapses back in on itself, though current observations suggest that's not likely. But here's what really gets me. None of these cosmic fates are remotely close to happening. We have trillions of years before the last stars burn out. The universe will still be producing new stars for tens of billions more years. By the time the cosmos faces any of these ultimate endings, humans, if we still exist in any form, will be unrecognizable. Our entire timeline, from the first single-celled organisms to whatever we become in the distant future, is just a brief early chapter in the universe's story. The real scary part isn't that space has all these existential threats. It's that the universe doesn't operate on human scales at all. We're not the center of anything. We're not the point. We're just here, briefly, in this narrow slice of cosmic time when stars are burning and planets are stable and life can exist. And eventually, that window closes. But you know what? That's also kind of beautiful. We get to be here at all. We get to look up at the night sky and wonder about these things. We get to build telescopes and send probes and figure out how the universe works. We're the universe trying to understand itself. So here's the final reality check. Yes, space is full of cosmic horrors, but the improbable, distant, theoretical threats aren't what we should focus on. The real dangers are much closer to home. Climate change, asteroids we're actively tracking like Apophis that could actually pose a threat within our lifetimes. Solar flares that could knock out power grids. These are problems we can actually do something about. Space isn't trying to kill you personally. It's just doing its thing on scales we're not built to worry about. And honestly, that's kind of a relief. Before we wrap up, I want to tease the next episode. We've mentioned black holes, neutron stars, and strange matter. In episode 5, We're going deep on the most extreme objects in the universe, magnetars with magnetic fields that could erase your credit cards from thousands of miles away, pulsars spinning hundreds of times per second, and yes, those mysterious quark stars. If you thought this episode was intense, you haven't seen anything yet. So hit that subscribe button and turn on notifications so you don't miss it. And seriously, let me know in the comments which of these facts got to you. Was it the gamma ray bursts? The rogue planets? The existential dread of timescales? I read every comment, and your engagement helps shape future episodes. If you want to support the channel and help us create more content like this, check out the affiliate links in the description. We've partnered with some great astronomy and science retailers, and using those links helps keep this channel running. Thanks for watching. Thanks for sticking with me through the cosmic horror. And remember, space might be terrifying, but it's also the reason we're here. Sleep well, or don't. I won't judge. I'll see you in the next episode.